In this video, we're going to continue talking about entropy in the second law of thermodynamics. Now, when objects go through state changes, the number of macrostates that they can have change as well. So let's talk about solid, liquid, and gas. So solid, the molecules there can't really move. All they can do is vibrate. So the level of microstates, or the number of macrostates they have rather, are very small. So solids are very ordered, and so they have very low entropy. Liquids are free to move now, and they're free to rotate, so they have a lot more different macrostates they can be in. Therefore, the entropy of a liquid is much higher than a solid. But gas have the most possible macrostates. That's because in a gas, not only can you rotate, you can move in 3 dimensions. You have a ton of movement for you. So gases have the highest entropy because they have the most macrostates. Solids have the lowest entropy because they have the least macrostates. Now let's just bring heat and entropy together. So if something's exothermic, we are adding heat to our surroundings, therefore that increases the entropy of our surroundings. Because things are moving faster, we may be able to melt something. We're giving it more energy. More energy for movement can be thought of as increased disorder. If something's endothermic, it's taking heat from the surroundings, and that decreases the entropy of the surroundings. When you take heat out of something, you're more likely to form a liquid from a gas or a solid from a liquid. You're slowing things down. They're becoming more ordered. And this amount of entropy change of the surroundings really depends on the original temperature. So let's say you're inside of a oven, it's 400 degrees, and you have a reaction that goes inside the oven that's exothermic. You're probably not going to change the entropy of the inside of that oven because it's already hot. So the hotter it is, the less of effect on entropy there will be. But we can have an equation that tells us what the change of entropy of our surroundings are. So we go back to this definition that we already learned about here in chemistry. The heat of the surroundings equals the negative heat change of our system, because energy has to go somewhere. So if we lose heat from our system, it goes and is absorbed by our surroundings. We can expand that to say, well, the entropy of our surroundings is equal to the change in enthalpy of our system, the negative change, because they are opposite signs, divided by temperature. And it's divided by temperature so we can take into effect that things at high temperature have a very low change in entropy. Things at low temperature have a very large change in enthalpy, or entropy rather. And that's it for this video. I will see you in the next video.